Hello guys, welcome back to my channel, Maths African Motives. Still working on the question paper for Maths N2, which was written in March 2019. An X paper. Remember, we managed to work on the first part of the question paper actually, so we shall have a continuation that is working with the other questions, and we just want to try and make sure that we actually finish up everything in this class. Remember, we worked with the first question, and that was the first question that we worked with. So if you didn't manage to watch that one, please make sure that you watch the video on this channel so that you can manage to at least work out these questions. All right, so we shall have a continuation, guys. As we can see on question number 2, we are given a condition where we are asked to fully factorize. Take note, guys, this is fully factorize the following expressions. All right, so we shall just quickly rush through the questions and factorize them. We've got 2.11 where we are given 12x squared minus 18x plus 6, like this. We are asked to factorize. All right, so what are we going to do, guys? This is fully factorized. So the first thing is to check if there is any term or any number that is common. Yes, it's a quadratic expression, but is there any number that is common? Yes, we have got 12, 18, 6 here. As you can see, 6 is the highest common factor of these three numbers, so you can factor out 6 first. That means we shall have 12x squared divided by 6, which is 12 divided by 6 is 2, so we shall have 2x squared minus 18 divided by 6, which is minus 3x. 6 divided by 6, which is plus 1. Remember this concept, guys, of factorization. Once you are at this stage, there is no way you are left with a quadratic expression, and as you can see here, the coefficient of x squared is not 1, so you are forced to apply the long process of factorization, which is the long process of multiplying the first term and the last term, which is 2x squared times 1, which is 2x squared. Then what are the factors of 2x squared which are going to give us the middle term, which is minus 3x? What are the factors of 2x squared? So as we can see, this is a negative middle term, so we have to at least have these terms being negative. So let's try negative 2x and negative x. Yes, if we multiply this, definitely we are going to have positive because it's negative and negative. If we add, we're going to obtain negative. So these are the two terms that you are going to substitute into the middle term. So we are going to have 2x squared, then you substitute these two terms in place of the middle term, which is minus 2x minus x plus 1, like this. Once you're at that stage, remember, you have got 4 terms now. 1, 2, 3, 4. So you have to group them into 2. So grouping these terms into 2 is going to allow us to factorize for the first 2 terms. Still, our 6 is still there. We are moving with this 6. We are moving with it. So now we are going to have something like this. What is common for these 2 terms? Because it's now by grouping. Remember, by grouping, you have to factor out what is common for the first 2 terms. As you can see, 2x there is common. 2 and x. X is the highest common factor because it's the one with the smallest exponent. Then we can divide. 2x squared divided by 2x. That's 2 and 2 cancel. X squared divided by x, which is x. Minus 2x and 2x is going to give us a negative 1. So remember that you are supposed to factorize again on these 2 terms so that the bracket that you're going to obtain here should be the same as this one. You must obtain the same bracket as this one. So take note, this is x minus 1 and this is minus x. It's not x, it's minus x. So what can we do so that this can be a plus x? We are going to factor out that minus like this. So you factor out minus 1 so that now it will be minus x divided by minus 1, which is a plus x like this one. plus 1 divided by minus 1, which is going to be a minus 1 like this one. So these two brackets must be the same, these two brackets. If they are not the same, therefore you are supposed to redo your factorization until you obtain this. You have to redo. All right, so anyways, this is what you're going to obtain. Since these two brackets are the same, you factor out this bracket of x minus 1 like this, which means if I factor out this bracket which is common between these two, I'm going to be left out here with 2x and minus 1. So this is going to create another bracket which is 2x minus 1 like this. So that is a simplified factorization that we are having. So this is to fully factorize, not to factorize partly, that you factorize another part then another part is not clear. No, this is fully factorized. All right, then another part there is on factorize again, and let's just see the type of expression that we are given there. It seems like we've got a difference of 2 squares there. So this is what we have. Remember, difference of 2 squares, guys, I told you that it's a condition where you are supposed to write this in terms of squares, like this. X squared minus y squared, we know that we take this x and y, this one, and we are going to have x minus y, x plus y, and x minus y. So that is what we want. So how can we write this 16 in terms of a number raised to the exponent of 2? So you simply find the square root of 16. That's it, which is equal to 4. So this can be 4 squared. Okay, what about this one? 36. 36 can be from, in order for you to find this, because what you need is to write x to the exponent of a certain number here, then to the exponent of 2. That is what you want. So you want this number here. What is going to be the number that you're going to multiply to 2 so that you're going to obtain 36 like this? So you simply divide 36 divided by what? By 2, which is 18. So this is going to be 18. So this is not this. It's just the same as x to the exponent of 18 to the exponent of 2. One and the same thing, because 18 times 2 gives us 36. So this is same as x to the exponent of 18 to the exponent of 2 minus, what about 1? 1 is just same as 1 to the exponent of 2. This one does not affect. So as you can see, we have got this condition of x and y. So we're going to take this number, the numbers which are raised to the exponent of 2, which is 4x to the exponent of 18. So this is what you're going to do, 4x to the exponent of 18 like this. Okay, plus this number here, which is 1. So one bracket is going to add, another bracket is going to subtract like this, just like x plus y into x minus y. But after that, cross check again if you are going to have another difference of 2 squares. Let's try the numbers. We've got 4. We've got, these are perfect squares, so which means we've got another difference of 2 squares here. So this 4 is same as 2 squared. Okay, x to the exponent of 18, you do the same like what we did here. So it's going to be 18 divided by 2 this time, which is 9. So it's going to be x to the exponent of 9 to the exponent of 2 minus 1 is same as 1 to the exponent of 2. So which means we can raise each and every number to the exponent of 2. So we shall have 4x to the exponent of 18 plus 1. The first part, it's not a difference of 2 squares. There is nothing like sum of 2 squares. So there's nothing that you're going to do here. So now you have got these two brackets now here from this difference of 2 squares, which is, we have got 2 and x to the exponent of 9. So it's 2x to the exponent of 9 plus 1. The first one is adding, then the other one will subtract. Okay, the matter of adding or subtracting does not matter actually. That is what you're going to have at the end. So as we can see, this is no longer a difference of 2 squares, because 2, you can't write 2 in terms of a perfect square like what we did for 4 to say 4 it's 2 squared. It's impossible for us to write 2 in terms of a number which is a real number, I mean a perfect number like 3, like 4, like 5. It's impossible. So this is no longer a difference of two squares. So you are done. That is, if you find the square root of 2, you are going to obtain it as square root of 2, which is a decimal. So that means it's not a perfect square. So that one, I think it's clear. We are going to work as much questions as we'll be moving on. So what you just need is to tune on and subscribe to the channel so that you won't miss these typical classes. Okay, so another part again is to factorize so another quadratic expression. As we saw that we have got 4 terms there. This is x squared plus ab minus ax minus bx, like this. So you've got 4 terms that we are supposed to factorize. That's 1, 2, 3, 4. So you have to do it by grouping, but by grouping now you have to check if there is anything that is common. So for the first 2 terms here, there's nothing that is common here, nothing at all here, there's nothing. So what am I going to do? I'm going to rearrange. So we have to rearrange in a way that we are going to factor out. So just looking this, we've got b here, okay, and we've got b here. So these 2 can be related together because there is something that has to do with b. Then here we've got x and x. At least we can take this together. All right, so let's just see if we are going to win. If not, we are going to rearrange again. So we are going to take this x squared and this minus ax, which are remaining, these 2 which are remaining, since we said we want to take these with b together, these 2 terms with b. So it's going to be plus ab, like this, minus bx. This is what you're going to have. So at least we have got x and x here, b and b, so something can work out there. So let's now group them into 2 and factor out the common terms there. So what is the common term? For the first 2 terms, you have got x, so it's going to be x. Now we have got something common, so x squared divided by x, we are going to have x minus ax divided by x. This will cancel. We are going to remain with minus a. So take note, guys, that whatever that you're going to factor out here, it must give us the same bracket as this one of x minus a, and our x is a positive. But this part here with x, as you can see, this part with an x here, it is carrying a negative. But this part is supposed to carry a what? A positive. Because that is the part with what? With x. So I'm going to factor out negative so that it can be a positive. But what is common? B is the one that is common. So I'm going to factor out minus b, like this. Okay, I want you to see what is going to happen. If you factor out minus b like this, you are going to have plus and minus, which is going to give us a minus. B and b will cancel, which means you're going to left with a, but with a negative. So it will be a because b and b is cancelled. You move on to this minus b and minus b. As you can see, they will cancel, which means it's going to be plus, and you're going to remain with x. All right. Someone is wondering, are these 2 brackets the same? Yes, these 2 brackets are the same. Why? Our x here is a positive. Our x here is also a positive. Our a here it's a negative. Our a here it's a negative. So these 2 are the same. But take note, x minus a like this is not the same as a minus x. This is wrong. These 2 are not the same. Because this is a positive x. This is now a negative, which is totally wrong. But this is positive and positive, negative and negative. So these 2 are the same, just like minus 1 plus 3 and 3 minus 1. These 2 are the same. So that means I'm going to factor out that common bracket, which is x minus a, because we said they are just the same. Then I'm going to be left with x and minus b. So this is another bracket now. So take note. Most of you guys, you take factorization for granted when you are doing your factorization, of which it's one of the confusing part if you don't revise it, it tends to be confusing, and most of you lose marks on factorization. To be honest with you guys, that is where most of you lose your marks on factorization. So if you are to consider factorization, you will see that your marks for N2, they are going to increase. They are going to increase a lot, because question number 2, it's all about factorization. Whatever that you're doing, you're adding, you're subtracting, you're multiplying, everything has to do with factorization. So it's very, very important. All right, anyways, let's just see on question 2.2. There, it's an advantage type of a question because already they factorized for us. So it's an advantage type of a question. So the question is just saying determine the LCM, which is the lowest common multiple. So this one, we can just write it here, guys. Remember, the LCM, you take everything that is common. I mean, everything that is present, every term that you can see, you have to take it. But if there are terms which are repeating, you take where there are more terms. All right, so we have got x minus 3, x minus 3. This one is just the same, so you're just going to take it once, x minus 3. All right, we have got x plus 2. It's repeating also here, so we just take it as it is, x plus 2. We move on to x minus 1. As you can see here, there is x minus 1 squared, which means there are many here where there is x minus 1 squared. So it's going to be x minus 1 squared. That's your LCM. You take every term. But the HCF, you only take what is common throughout the whole expression, what is common. So let's check. Do we have anything that is common? We do not have. X minus 3 is not there. Here we do not have x minus 3 on the second part. X plus 2 on the third part, we don't have x plus 2. X minus 1 on the first part, we do not have x minus 1. So therefore, what is your highest common factor? It is going to be a 1. Take note, guys. It is going to be a 1. That is what is common there. All right. Now let's see the other part. Simplify the following expressions on 2.31. Okay, these two, they are adding. So definitely someone has to do some factorizations there so that you can actually simplify further. But which factorizations are we going to do here? Which factorizations? Let's see what we are given in this type of a question, and this is actually 5 marks, which means there's something that is important there. All right, anyways, this is what you're going to do. You just factorize this separately. Just do your factorization separately. 3x squared minus 3y squared, that is our denominator here on the first fraction. That is what you factorize. So as you can see, 3 is common, so you can factor out 3. You're going to be left with x squared minus y squared, which is a difference. This is actually a definition of difference of two squares. So if you can't see that this is a difference of two squares, then guys, it means we have to revise, because that is a definition of difference of two squares. So which is x plus y into x minus y, like this. So that's what you're gonna have there. So as we can see, this is gonna be 9 over 3 into x plus y into x minus y, like this, plus x over, we have to factor out what is common here. So as you can see here, it's direct. X is the one that is common. So if I factor out x, I'm going to be left with y minus x squared divided by x, which is x. All right. Now this is the most important stage where most of you lose marks. This is the stage. How do you lose marks here? Most of you, what you do is that you just take, okay, this is it. I'm going to take this as my LCD, write everything. No. It's not like that. Before you do that, make sure that you cross-check your denominators. It is very, very important to check your denominators. For terms like this, where we have got x minus y and y minus x, these two, they are not the same, because this is plus x, this is minus x. This is minus y, this is plus y, so these two are not the same. But you can make them to be the same by introducing what you just do, guys. Note this. Note this one, please. You have to note this. Just introduce a negative there. Introduce a negative on the second fraction. On the second fraction. All right. The moment you introduce a negative on the second fraction, it means the brackets will automatically be the same. The brackets will be the same. Or the brackets will be equal. That is what I mean. These two brackets, these ones that we are talking about, they will be actually automatically be equal. We'll talk about this maybe if we are going to talk about as a topic on fact, but I think when we did factorization, I talked about this actually, these typical types of fractions. So make sure that you watch the video on addition and subtraction of algebraic fractions. All right, so this is it, guys. Let's write another stage. So this one we talked about it, and also here we can actually divide 9 and 3, because this is outside. So 9 divided by 3 is going to give us 3. So we are going to be left with 3 there on top. So it is going to be like this: 3 over, remember we divided 3 into 9, which gave us 3, over these two brackets. All right, x plus y into x minus y, like this. Remember what I said, we want these two brackets to be the same, so we are going to introduce a negative. So you introduce a negative, remember I said on the second fraction, which is the following fraction, this one, and it is the one that is going to change. All right, that is what you're going to have. And also here we have got x and x. These two also can cancel, as we can see. X and x can cancel. Then we have the part of introducing a negative, so that these brackets will be the same. So we are going to introduce a negative, which means negative and plus gives us a minus. If this was already a negative, when you introduce a negative, it means you are going to obtain a plus. But because it is a plus, so when you introduce a negative, it will be a minus. Okay, remember x and x cancelled, so we've got a 1 there on top. So it's 1 over this one. We said after introducing a negative, the brackets will be equal. So this bracket and this bracket will be the same. So we are going to write it as x minus y, like this one. So you relate it to the first fraction because you want to change the second fraction. So you are going to relate it back to the first fraction, like that. You are done. So as you can see, you can now find your LCD. So what is our LCD? So we've got x plus y, which is our LCM, x plus y there, and x minus y, which is the same. So it's just going to be x minus y, like that. So now you can divide our LCD, divide by the denominator here. So this and this will cancel. So this and this will cancel. So, but you don't cancel, you just assume cancelling. So which means you're going to remain with 1 times 3, which is 1 times 3 minus, you are at this stage, this one, and divide. So as you can see, x minus y and x minus y will cancel. So which means you are going to be left with x plus y. So it will be minus 1 into x plus y, like this, because this one and this one cancel, but you don't cancel them, you just assume cancelling. Now we have this stage where we have to expand 1 times 3, which is 3, minus 1 times x, which is minus x, minus 1 times y, which is minus y, like that. Everything into x plus y into x minus y. So at that stage, there's nothing that I can do. At that stage, you do not have anything that is common, because here it's separated by a minus, so you can't cancel. Okay, you can't cancel at that stage. You are just gonna write it like that. So that is how you were supposed to answer these typical questions. So what you just need, guys, is to revise as much questions as possible. Let's see another one, which is also to simplify again, and it's actually 4 marks there. So this is 2.32. We have got 1 minus 1 over x minus 1 like this, then everything like this over x squared minus 1. All right, don't be afraid on such typical questions like this. What this simply means is that this part here, as you can see, everything is going to be divided by x minus 1. So you can actually rewrite this as 1 minus, like this, 1 over x minus 1 like this. This is one thing from the, because it's on the numerator, so this is actually one expression. Divide by, because this is going to be divided to x squared minus 1, which is actually can be written as over 1 like this. Remember, just like 2 can be written as 2 over 1, 3 over 1 like that. So that is what it actually means. So if you can have a mind like this, it means you actually know that this is not the same as writing or as simplifying this separately, then you divide to this part. Working out this separately, that is what it means from the brackets. So what are we going to have? 1 minus 1 over x minus 1. We have got to find the LCD of the two, which is x minus 1. 1 and x minus 1, remember. So x minus 1 divide by 1, it's going to be x minus 1. Then you multiply by 1, so it's 1 into x minus 1 minus, take note, x minus 1 and x minus 1. These two will cancel, but you don't cancel. So 1 times 1, which is 1 like that. So now you can expand brackets and simplify further, which is going to give us something like 1 times x, which is x, 1 times minus 1, that's minus 1, and we already have a minus 1, which is there, over x minus 1. So this is going to be minus 1, which is minus 2. So this is what you're going to obtain from the numerator, which is x minus 2 over x minus 1. So we are going to have it like this, x minus 2 like this, everything over x minus 1. So that is what we obtained here from these two, x minus 2 over x minus 1. But now if we are to cross-check there, if we are to cross-check from this part, we are going to see that this is being divided to this, which is the same as we are multiplying to 1 over, take note, when you divide you introduce multiplication, so it will be 1 over, you invert these two, so you're going to write x squared over 1 here, but we know that x squared minus 1 is same as x squared minus 1 squared, which is actually difference of 2 squares, so it's gonna be x plus 1 into x minus 1 like this. Most of us, we target to cancel at this stage, which is true, but at this stage, as we can see, we do not have anything that can cancel, but we can actually multiply the numerator to the numerator, which is x minus 2, that is our numerator there, over, you multiply the denominators here, so it's x to x minus 1 and x plus 1, so it's going to be x plus 1 like this into x minus 1 squared, or you can just write it as x minus 1 into x minus 1 like that. We do not have anything that is going to cancel here, because this is x minus 2. You don't cancel the numerators, these two, no, these, they only multiply each other. But if it was in the numerator, then you can cancel, but in the denominator it's impossible for us to cancel, so which means you just have to leave it like that. That is what we had. And let's see what we are having on question 3 there. So these typical questions like what we are seeing on question 3, you need actually to understand how you answer these questions. You need to understand everything on answering the questions. All right, they were asked to determine the values, or it's actually the value of values, so it can be one value or they can be values of x. in the following equations by means of what? By means of factorization. All right. So we have to apply the means of factorization. Here we have got x, okay, this is 3.1 actually. We have got x minus 2, x plus 3, which is equivalent to 6. So how can we apply our factorization concept in this case? How can we apply the factorization? So someone can say this one is already factorized. Yes, it's already factorized, but this is wrong because remember it's not equal to 0. It's equal to a certain number. So definitely I have to take this number back to this part. So which means we have to expand first, then we redo the factorization that we are supposed to do. So it's gonna be x and x, which is x squared, x and 3, which is 3x. Remember, we move on to minus 2 and x, which is minus 2x, minus 2 and 3, which is minus 6. So this is what you're going to have, guys, from this part. Take note, you have multiplied x for every part, then minus 2 for every part again. Then you can take this 6 to the other side of the equation, which is going to be minus 6 like this is equal to 0. Every quadratic equation should be equal to 0 so that we can actually solve properly. Now at this stage we are going to have x squared 3 minus 2. These are like terms, so it's plus 3 minus 2, which is plus 1. So it's going to be plus 1x, which is just 1x, minus 6 minus 6, which is minus 12 from our calculator there. Now we are left with a normal quadratic expression which is equal to 0. Now we can do our factorization. So remember how you factorize, guys. This is actually the coefficient of x squared here is a 1. So remember, if the coefficient of x squared is a 1, just put in x here and x here. So what are the factors of minus 12 that we are going to add to give us a plus 1? Because here we've got 1x, which is x like that. So it's going to be like plus 1. So what are the factors of minus 12? So we've got 4 and minus 3. 4 times minus 3 is minus 12. If we add, we obtain a 1. So you've got plus 4 and minus 3 equal to 0 like that. So that actually means that each bracket must be equal to 0. This bracket should be equal to 0. This bracket should be also equal to 0. So by doing that, x definitely is going to give us a negative 4, or another x is going to give us a positive 3 there, because it's like x plus 4 is equal to 0 like that. Then you transpose, so it's going to be negative 4. The same thing with minus 3, you transpose, it's going to be a plus 3. So that is what we have on this typical question. Then you can just cross check if these values of x are going to satisfy the equation or not. If they are satisfying the equation, therefore it means these values, they are correct. So that is what we had. Then we have got on 3.2, like I said, these word problems, you have to be very, very careful with them. The sum of two integers, take note, the sum of two integers is 41. So we've got two integers that we do not know, which is 41. 3 times, okay, so let's just talk about the integers first, the two integers that we do not know. So let x and y be the integers. All right, because we are just given integers here. We are not given that this integer they are following each other. No, they just said integers. So x and y can be any integer. All right, so now they are saying the sum of the two integers is 41. So x and y, that is the sum. You add x plus y is equal to 41. We have formulated an equation there. Then when 3 times, take note, when 3 times the smaller integer is subtracted from the larger integer, the result is 17. we do not know which one is going to be our smaller integer or whatever that we have, but they are saying when 3 times the smaller integer is subtracted from the larger integer. So in this case, I'm going to refer my x as the smaller integer and my y as the larger integer. All right. So they are saying that this 3 times is subtracted from this, so it means y minus 3 times, take note guys, 3 times the smaller integer, which is 3x, that's our smaller integer, is subtracted, which means y minus, because it's subtracted from the larger integer, then the result is 17. This is going to give us sorry, this is minus 3x subtracted is going to give us 17. That is the result, which means it's equal to 17. So y minus 3x is equal to 17. So you have to solve the equation. Actually, solving this type of an equation, there are so many ways you can apply: substitution, elimination, whatever that you want. So we've got equation 1 here. Most of you guys, you love to use substitution, so I'm just going to use substitution, but substitution now depends with which one do you want to make the subject. So in this case, I am going to choose to make the subject on equation 2. This one, I'm going to make y to be the subject on equation 2. The subject in equation 2. This is for me, this is what I want. So y is going to be equal to, transpose this negative 3 to the other side, is going to be positive 3x plus 17, which was already there. So now I'm having equation 3. So I'm going to substitute equation 3 into equation 1. Since I made 2 to be my subject, so I can't substitute here. I have to substitute into equation 1. If you made y here, then you're going to substitute on equation 2. You choose which one is your best there. So substituting on equation 1 is going to be x plus, take note it's x plus y, and our y is 3x plus 17. So 3x plus 17 is equivalent to 41. So this is just solving, guys. You choose which method is best for you. So you can add, because this same is 1 plus 3, which is 4x, is equal to, transpose this 17 to the other side, is going to be a minus 17. So that's 41 minus 17, which is 24. Okay, don't know, 24, something like that. Divide by 4 by 4, definitely your x is going to be 6. So remember, we already have y as the subject, where we said y is equal to 3x plus 17. So we can just find the value of y there. So this is just a t, guys. The x is 6 there. We said y is 3x plus 17. So in place of x, we're going to substitute 6. So which means the value of y is going to be 35. So that is our x, the smaller integer, y, the larger integer. Do they make sense? If we add them, are they going to give us 35 and so forth? Okay, just try. So the question was just to find the two integers. So these are the two integers, 6 and what? And okay, therefore the two integers 6 and 35. Yeah, you can just maybe give them something like that, but not necessary. Okay, on 3.2 you are given a wheel with a diameter 600 millimeters has a rotational frequency. You've got the rotational frequency. So when you're answering these typical questions, take note of the units that you're going to use, and also what guides you is the topic that you are answering and the units that you're supposed to have. Remember, always the diameter is supposed to be in meters and so forth. So let's just take our information, then we just do the rounding later on. So on 3.3 we are given a diameter of 600 millimeters. So you can actually maybe convert to meters, because as you can see, meters per second, what. So we need this in meters. So if we divide, because milli, you have to divide by 1,000. So if you divide by 1,000, this is going to give us 0.6. All right. Yeah, that's 0.6 there. All right, meters. So this is our diameter there. And we have got the rotational frequency in revs per minute. So this is actually in revs per minute, guys. Take note. Our n there is 200 revs per minute. So let's just write it. We will convert if there's a need for us to convert, because we know we can write this in revs per second where we have to divide by 60. So it's going to be 200 over 60 like this. Then it will be in revs per second. That is when we need it in revs per second. So let's see. The first question is calculate the following 3.31, the rotational frequency in revs per second. So that is what they are actually asking us. This part that I was writing actually. So this is 3.31. So our n, let's just write it a small letter because it's now in revs per second. So it's just gonna be 200 over 60 there, which is as a decimal is gonna be 3,333333333 and so forth, or 10 over 3. Yeah, that's the best way actually, because this is actually 10 over 3. All right, which is in revs per second, or you can be 3,333 revs per second. So it depends, 10 over 3 or this one, because it's just one and the same thing actually. All right, then the peripheral velocity in meters per second. Peripheral velocity, this is the v velocity, this one, which is equal to pi dn, which is there on your formula, and this n must be in revs per second. All right, so that is your peripheral velocity v on 3.32, which is equivalent, we said it's pi dn. All right, and this is in revs per second, so that it will be in meters per second. All right, so this is pi, the diameter in meters, so times the d, which is the diameter in meters, and we said our diameter in meters is 0.6 here, so we are going to have 0.6 times n. So now our n, remember guys, this is our n in revs per second, and we've got two answers, this one of 10 over 3, or we can use pi times 0.6 times this one of 3.333, something like that. Remember, we obtained and two answers depending with what you're going to use or what you want to use there, but that is what you're going to have. So using the 10 over 3, this one is just gonna give us a direct 2 pi. So this will be 2 pi meters per second. Actually 2 pi meters per second is something like 6 something like that, 6,283,185. all right, which is going to be 6,283 decimal places meters per second. So that is what you are going to have. So it depends with what you have, so you can use this or you can use this. As for me, I'm gonna depend with my 10 over 3. Working with a fraction is much easier for me than to work with the decimal. So this is it. So you can choose this one, but you're going to obtain an answer which is slightly different. It's not going to be like direct, it's going to be slightly different, but this doesn't matter. It doesn't matter at all. It doesn't matter, that one. Then the angular velocity in rad per second, this is that one, angular velocity like this, omega, this one, this is your omega, which is measured in rad per second, and the formula is there also on your formula sheet they give you if you do not know it. But if you know it, then it's an advantage. You just write it, that omega is equivalent to 2 pi n, all right, which is in revs per second. So it's 2 pi times n. Remember our n, we have got two of them, the one in as a fraction, which is our 10 over 3, or this one of 3,33. So it's going to be 2 pi times 3,333. So that is what I mean. So if you use this one, you're going to obtain 20 pi over 3, which is 20 over 3 pi, which is in rad per second. All right, of which you can maybe just write it as a fraction, which is going to be 20,94345, yeah, something like that, which is going to be 20,943 3, because this 4 cannot change 3, which is in rad per second. So you can maybe just have it that way or write it that way. I don't know, depends with what you want, guys. So using this one, you're going to obtain still another part or another version which is slightly different, but it will be the same thing. Don't worry about that one, it's just one and the same thing. All right, then we are asked to convert this part to radians. Okay, we have to convert to radians. So definitely I can't convert to radians direct, but I know that I can actually convert degrees to radians, because there's a relationship between degrees and what, and radians, and converting whereby you can divide by 57,3 the angle that you'll be given in degrees. So as long you are in degrees, there can be something else that can work out. But look, we have got 60. Okay, let me write it down and see what we have. It's not a direct question that we are given, because we have got 60 degrees, 30 minutes, and the other one there is actually a mistake. This one is a mistake. It's degrees, minutes, then it's supposed to be seconds. So it's supposed to be like this, 36 seconds like this. This is what it was supposed to be like. That is to represent seconds. All right. Now this is it, guys. We have to convert so to degrees. So we are going to convert this to degrees and also this one to degree, but it's easier for us because we know that 1 degree is actually equivalent to 60 minutes, and in a minute we have got 60 seconds. Remember the relationship, guys, that we have. 1 minute is equal to 60 seconds. So which means you can convert these seconds to minutes first, then you can convert your minutes to degrees. So let's start with these seconds. So how am I going to convert these 36 seconds to minutes? So 36 seconds to minutes, actually you're just going to divide 36 divided by what? By 60. Okay, that's 36 divided by 60, which is 0.6. So this is going to be 0.6 minute. So it's now in minutes. So if this is in minutes, it means it can be added together to this so that we combine these minutes. Okay, so we are going to have 0.6 minute plus 30 minutes, which is just this one, guys. As you can see, this there is a 0 here and this is a whole number 30. So 30 plus 0 is just 30.6 minutes, or you can just use your calculator. 0.6 plus 30. So we are now having 30.6 minutes. So the question is now like this: 60 degrees, 30.6 minutes. But we said we can only convert if we only have degrees direct. So which means we have to convert this now to degrees. And which conversion are we going to do? This one that we say that in a degree there is 60 minutes. So in a degree we have got 60 minutes. So what about 30.6 minutes? 30.6 minutes. What are we going to have in degrees? We do not know. We actually do not know. So we are going to divide. All right. So we are going to divide here. That's 30.6 divide by 60. All right. So we have to obtain something like 0, that's 0.51. So this is gonna give us 0.51 actually. 0.51. All right, which is now in degrees. So remember, what we need is to have it in degrees. So we are going to add them: 60 degrees plus this part that we have, which is 0.51 degrees, which is just 60 plus 0 there, 60.51 degrees. So everything now is in degrees, so we can convert to radians. Why? Because there is a relationship between radians and degrees, to say that theta in radians is equal to theta in degrees over 57.3. For you to convert to a theta in radians, you have to use theta in degrees over 57,3. This is what you're supposed to know there. So which is this, your theta in degrees, this one, 60,51 over 57,3, and this will be in radians automatically, which is going to be 1,05, that's 0.560209, something like that, which is 1,056, yeah, something like that. So that is your theta in radians. So take note, guys, take note of the way that you're going to answer and present your answers. And if you actually know like the stages that you are gonna face and so forth, you'll see that some of these stages, they are not even necessary at all. They're not even necessary at all. But anyways, that's what you did there. Now the other question is, we are given that a thin piece of metal plate in the shape of a circle sector. The angle of the arc is 0.5 radians and the radius is 86 centimeters. All right, 85 centimeters, which is, we have got the angle in radians, which is 0.5 rad, which is our theta, and the radius, which is 85 centimeters. Remember, it's supposed to be in meters. So we divide by, in a centimeter, in a meter, we've got 100 centimeters. So we have to divide by 100, which is 0.85 meters. All right. So we just have a sector, something like this. Okay. Well, let's just see what we are given so that we can at least talk from that thing. So that's our sector there. And we know that we are going to have this as our center. Let's just say we've got A and B like this, and this is our radius, which is 0.85 meters here, 0.85 meters, and this is your theta in radians, which is 0.5 rad. All right. So the question is, determine the cost involved to treat the plate, which is the metal plate, which is the sector one, on one side against rust at a price of 55 rand per square meter. So per each square meter you are required to provide 55 rand. But how many square meters are we going to have for this one? We just need the area. So what is the area that we are going to work on? So we need the area of the sector, and we know that the area of the sector is given by the formula half r squared theta, which is measured theta in radians, and this is the radius. So it's half times the radius in meters there, because we are measuring per square meter. So it's going to be 0.85 squared times our theta, which is the angle in radians, 0.5. So using our calculator, we are going to obtain 0.180625, something like that, which is 0.181 square meters. This is our area. And as you can see, this area is actually less than a meter, because here we are given that the cost is going to be 55 rand per meter, and our area is less than a meter. This is 0, a meter. We are talking about 1 square meter, and 1 is greater than 0.18. So which means the cost actually is going to be less than. Okay, anyways, how do you do it? Remember, if each meter requires 55 rand, therefore what about 0, which means the cost, you're just going to multiply the area that you obtained to the cost per square meter, and the cost per each square meter is 55 rand. So you're going to multiply by 55 rand, which is 55,00. So if you multiply by 55, this is going to give you 9,955, something like that. But this is amount, guys. The amount always should be to two decimal places. Yes, the instruction of the question paper says leave your answers to 3 decimal places and so forth. But if you are referring to amount, which is the cost, your answer should be 2 decimal places. So this is going to be 9,96. Take note, we do not have a condition. Yes, we have these conditions, but when we are presenting our answers, let them be to 2 decimal places. Okay, this is what we are used to, what we know, and it's not like you cannot write 3 decimal places and so forth, but try to just save it like that. Okay, 3.6, we are given a lead sphere with a diameter. We are given this is a sphere, and we are given the diameter of the sphere 15 centimeters is melted and recast into multiple smaller spheres. All the smaller spheres have a radius of 20 millimeters. Take note, there we are given a radius of 20 millimeters. On the other side, we are given a diameter of 15 centimeters. All right, so the question is calculate or determine the volume of one smaller sphere in cubic millimeters. One smaller, the smaller one. And we are given that all the smaller spheres have radius of 20 cubic millimeters. All right, so we are given the radius, which is direct on this. So I'm going to use the small letter r for the smaller sphere. So you've got the radius there of 20 millimeters. And remember, guys, for a sphere, that the volume of a sphere, so this is the smaller one, is equivalent. Okay, the volume does not change. It's 4/3 pi r cubed. That is the volume of a sphere, but I'm going to use the radius of the smaller one, and it's already in millimeters, and it's 20 there. So it's going to be 4/3 times pi times 20 cubed, like this. Okay, and this is going to give us this big decimal 33510,32164, yeah, something like that, which is 33510,322. If you round off to 3 decimal places, it's going to be 22 there in cubic meters. All right, that is the volume of each smaller. Take note, each smaller, not the all of them, because we are given that we made this space, but we just want each smaller. Okay, then we are now given that the amount of smaller spheres created. How many smaller spheres were created? Okay, this is the concept here. Remember, we created these smaller spheres from a larger sphere, which was this one with a diameter of 15 centimeters. So let's find out the volume. That is it. We just need to find the volume of the larger sphere. Then we divide to the volume of the smaller sphere that we have. But this is in cubic millimeters. So try to find the volume of the larger sphere in cubic millimeters also. So this is it. We are given here, which is our diameter. And remember, we have to find the radius there. Okay, so this is the smaller sphere. The smaller sphere, which is on 3.61. All right. Then on 3.62, we said let us first find the volume of the larger sphere. So we need the radius. So I'm going to put it as capital letter for the larger one. So the radius first, it's 15 divided by 2 because we are given diameter, which is 7,5 centimeters. But we said the volume is already in millimeters, so you have to find it in millimeters. So we have to write this radius in millimeters. But remember, in a centimeter, we have got 10 millimeters. So you just multiply by 10, which is 75 millimeters. All right. So therefore, the volume of the larger sphere, so the formula is just the same, guys. 4/3 pi r cubed, but this one is for the bigger one, so we're just gonna write it as r cubed like that, which is 4/3 times pi times the r, this one, which is our r cubed, which is 75 cubed, like this. So definitely we are going to expect a bigger value than the one that we had before, which is 17 67,145, comma 86. This is gonna be 868, something like that, if I'm not mistaken there. Yeah, that's 176,71458. Yeah, so this is the volume of the larger sphere, but what we need is to know how many smaller spheres are going to be created if they were created from this larger one. Therefore, how many, because we have got the volume of the smaller and the volume of the larger one. So what you just need is to divide. So the number of smaller spheres, the number of smaller spheres is just going to be the volume of the bigger one, which is 176,745, comma 868. So you just take this value as it is, you divide to the volume of the smaller one, and remember the smaller one, it was 33510, comma 322. Remember here guys, that was the volume of the smaller one here. So if you divide, you are going to obtain 52,75, something like this. So how, guys, we are talking about how many spheres were completed, how many smaller spheres were created which has got such a radius. So these are 52 in total. So we have got 52 spheres created, smaller spheres. Just like you have got a glass, okay, you got a glass of wine that we have, then you pour wine into this wine glass, then you obtain maybe the number of the wine glasses that you obtain. They are 32,857, like this. The number of the wine glasses that you filled were 32. Those are the ones that were filled. The comma represents another glass which was not full. We do not know, maybe it was this way. But if we are referring to a total shape which was created, there were 32. So it's the same thing with this part here. The total spheres which were created, complete spheres, were 52. The other one, maybe it couldn't manage to complete a sphere like this, so it's totally out of our answer. So the answer will be 52. Take note how you will present your final answer there. So that is it, guys. You just need to understand the basic of the question that you'll be given there, and you will see, okay, I want this part here. All right. Then on question 4, we are given that a college yard is divided into parallel strips, 6 meter interval, or the length of the strips. So these are your parallel strips. So we are asked to calculate the area. So remember, guys, from your area, that is when you are given the strips like that, that is your area is going to be the first. So you're going to have the first ordinate plus the last ordinate, first ordinate plus last ordinate over 2. So okay, let's just write that you know the formula you'll be given. So I'm gonna write it as first plus last. That's first plus last over 2 plus sum of the remaining. So you've got sum of the remaining ordinates here that you are going to have times the distance between, which is the interval. So this is the distance between, which is the interval. So the formula you are given, guys, on your formula sheet, so we're not gonna waste much time there. So the area is first and last ordinate. That is what is important. What is your first and your last? So these are your arrangements here. So that's your first ordinate and this is your last ordinate according to the way that they are presented. So it's 5 plus 5. 5 plus 5 over 2. That is first plus last. Plus the sum of the remaining ordinates. We are going to add all these remaining ordinates from 9 up to 10, up to that 10. So you add all those ordinates. So you've got 9 plus 14 plus 19, that's 19 there, plus 24 plus 30 plus 22 plus 15. Yeah, you add everything up to 10. So this is up to 10 plus 10. All right, let's write our plus 10 here. So this is what you're going to have. Then times the distance, which is the interval of 6 meters. So you're given that there is 6 there. So you multiply by 6. So that is it. So as you can see, guys, just simplify this. 5 plus 5 is 10. 10 over 2, which is 5. So you're going to have 5. So this is no longer there. You are going to use 5. So you add 5 plus 9 up to 10. So if you add all those numbers, you are going to obtain 153 times 6, which is going to give us, suppose there's a 6 here. So 153 times 6, which is 918. So that is our area in square meters. Take note, these units were in meters. So your area is going to be in square meters. That is what you're going to have as your area in square meters. All right, another part on question 4.2 is to determine the value of theta in radians. Take note, guys, determine the value of theta in radians. But we are given this in degrees, so you have to find our theta first in degrees. If cot theta is equal to minus 0.5. Cot theta, what does cot theta mean? Okay, let's just write cot theta is equivalent to minus 0.5 like this. And we are given an interval that is supposed to be between 270 and 360. All right. Cot. Where are we taking this cot from? Cot is actually taken from tan. So this is it, guys. We can write our cot, because remember, cot is 1 over tan. So I want you to understand, you're going to write it like this: 1 over tan theta like this. That is cot is equal to negative 0.5. All right. Then you want to find tan. So you're going to cross multiply 1 times 1. Tan times minus 0.5. So you're going to have minus 0.5 tan theta, which is equal to 1 times 1, which is 1. So, which means to find tan, because you need to write a trig, so you're going to divide by negative 0.5 like this. So you're going to have tan theta is equal to 1 divided by this, which is negative 2. Okay, so this is negative 2 for tan. Now we have a trig ratio that we are used to. We are used to tan, guys. So we actually know from our quadrants, all students take calculus, that tan is negative in this quadrant and in this quadrant. But there we are given a reference from 270 to 360. So which means they want us to use this quadrant, because remember it's 0, 90, 180, 270, 360. So that is what you have there. So from 270 to 360, which means this is the quadrant that we are going to have our tan in this quadrant. That is where we are going to have our tan. So what is the angle theta in this quadrant? That is what we need. All right, so what is our theta? So remember, for you to find the theta, you have to find the reference angle first. You are going to find theta by finding arctan of the angle. The negative is there for the quadrant, so you find arctan 2, which is your reference angle there. So arctan 2 is going to give us, so this is our reference angle actually, which is arctan 2, which is going to give us 63. Yeah, that's 63.435 degrees. Yeah, something like that. That is what you're going to have. Yeah, that's what you're going to have as our theta there. But this is the reference angle. All right. So the reference angle, I'm just referring to this angle that you have in each quadrant like this. So this is where you're going to have your reference angle here, but the actual angle now is the one that you are talking about, this one. So what is going to be the actual angle now, because this is your reference angle, and in the quadrant, this one, the fourth quadrant, remember, how do you find the actual angle? The actual angle, okay, let's just theta, which is the actual angle, is going to be 360 minus 3. In this quadrant is going to be 360 degrees minus the reference angle. All right. So you subtract 63,435 degrees like this. So if we subtract this from 360, we are going to obtain 296,565 degrees as our theta in degrees. But they need this theta in radians. Remember, all this is for us to make a simpler conversion to obtain what is needed in radians. So now we can convert because our answer is needed in radians. And remember, I told you about this relationship that theta in radians is equal to theta in degrees over 57,3. So we are going to have our theta in degrees 296,565 degrees over 57,3. So we shall have our theta, which is now in radians, which is going to be 5,17564, something like that, which you can round off as 5,76. Is that so? 176. Yeah, this is in radians. Okay, that's our theta there. Yeah, you can just do that conversion. I mean the rounding off to 3 decimal place and so forth. Yeah, depends with what you actually, the way that you understand it and how you wanna write it, maybe. Okay, on 4.3, Mr. Kanya there is standing 20 meters away from a tree. Okay, 20 meters from a tree. He measures the angle of elevation to the top of the tree as 38 degrees. Okay, this is what is happening here. Remember, angle of elevation, how you do it, that this is the tree here. Let's just say this is our tree. So Mr. here is standing 20 meters away from the tree, which means somewhere here, 20 meters away. That is where he is standing here, which is 20 meters away. Take note, where he is standing and the tree, there is a distance of 20 meters. Then he measures the angle of elevation to the top of the tree. Remember, the angle of elevation you measure from where you are to see to the top of the tree here. This is the top of the tree. Then the angle that was measured was 38 degrees. That is your angle of elevation. Determine the height of the tree. Ignore the height of Mr. Point. So we are going to ignore the height of Mr. and we need the height of the tree, which is this one. This is your tree, remember. So we need to find this height. So let's just say the height of the tree is X, or the height of the tree is H, or whatever that you want to write. So what are we going to do, guys? This is a right angle triangle that is going to be formulated, because where the person is and the tree is going to meet at 90 degrees, because you've got a horizontal line versus a vertical line. All right. So that means, according to this 38 degrees, this is your opposite and this is your adjacent. According to 38 degrees, this is your opposite adjacent. So there is only one ratio which uses opposite and adjacent. It's only one from your SOHCAHTOA. There's only one ratio which has got opposite and adjacent, and that ratio is for tan, and that is the one that you're going to write. Tan theta is equivalent opposite over adjacent. So you've got tan theta, which is our theta is there, 38 degrees, which is equivalent opposite over adjacent, and our opposite is the one that we want to calculate, which is X over the adjacent, which is this measurement of 20 meters. So that can allow us to calculate the value of X, which is the height of what? Of the tree. How? by cross multiplying 1 times x, which is x is equivalent to 20 meters times tan 38. So it's going to be tan 20 tan 38. This meter does not need, we're just going to write it on our final answer there. So 20 times tan 38, which is going to give us 15,625712, something like that, which is 15,6 and this is going to change to 6, all right, which is in meters because every measurement was in meters. So definitely your final answer is going to be in meters there. All right, that's what we had from this part. So guys, you have to be very, very careful how you answer these typical questions. It's very, very important how you answer these questions. All right. Then on question 4.4, we are given to draw those graphs. All right. How are we going to draw these graphs, guys? We are asked to draw the graphs of cos x plus 1 and sin x plus 1 in this case. So I have this part. I don't know if it is going to work for us, but I have got this part here that we are going to use. Okay. So we have got our angles here. That's 0.91827,360. This is wrong. This is wrong because this is supposed to be 0 here, not here. 918. So this is actually a mistake that was done here. I don't know. Let me just find another way. So what we actually need, maybe let's just save our table first, then it can make sense. Because here we know that we are going to have something like this. F of x is equivalent to that's cos x plus 1, this one. Okay, so remember we're given from 0 to 360, right? So let's just create a table here from 0 to 360. That's something like this. All right, that's something like this, guys. That's our x. Remember it's x there and y. Okay, so I'm just gonna use 90-degree interval, 0, 90, 180, 270, 360. So remember your interval, guys, you add 90, 90, 90, 90. Like I said, I'm using 90-degree interval. So it's 0, 90, 180. So you'll be adding 90, 0, you add 90, 90 plus 90, something like that. Okay, so make sure that now your calculator is in radians. Okay, so you're gonna substitute here. In place of x, you substitute 90. Make sure that on your calculator it's like this. It's cos 90, it's cos 0 like this. You close the bracket, then you say plus 1. After closing the bracket, that's when you write plus 1. So your answer is going to be 2. All right. Make sure your calculator is in degrees. Make sure your calculator is in degrees. Okay. You move on to 90 degrees. You do the same, cos 90 degrees. You close the bracket. Okay. So your answer is going to be 2. Here is going to be 1. Here 1 and 2. That is what you're going to do. You do the same for sin x plus 1. This was gx is equivalent to sin x plus 1. You do the same again. Just create a table. So simple like that. So you've got x and y there. All right. You do the same, 0 to 360 degrees. All right, that's 270, and this is 360 degrees, something like that. So you just do the same. You substitute 0 here. So make sure it's sin 0 like this. You close the bracket first, then you say plus 1. So this one is going to give you 1. You do the same, 90, close the bracket. This one is going to give you 2, 1, 0, and 1. All right, so these are the values actually that you're going to have from cos x plus 1 and from sin x plus 1, and we can actually use our graph in this case. Remember, so I'm just gonna put this way here. I don't know if it is going to be much clear here, but I'm just gonna use this one. I hope it is going to be clear for what I want to present here. Let's hope it is going to be clear on what I want to present. All right, so I'm just gonna divide here like this, and it's very cold, guys. All right, something like this. So this is my x and my y. So okay, let's just put this as x. So this is 0 here. So I'm just gonna put here 90, 18 up to 360. So I'm gonna separate this box here to represent my 90, my 18. So it's 0, 90, 180, 270, and that's 360 for me. All right, then here this one is for y there. So I'm just gonna put 1, 2, 3 going up, 1, 2, 3 going upwards, maybe, yeah, something. And we do we have any negative there? I hope we do not have any negative, so there's no need for us to write any negative there. So let's start with this one for cos. So it's 0 versus 2, 0 versus 2, okay? 0 for x and 2 for y. So it's gonna be here. That's 0 versus 2. 90 versus 2. So it's 90 versus 2. Was it what? 2, guys? This is 1. This is 1. I don't know what happened, but this is a 1. This one. All right? Because remember, cos 90, it's 0. So 0 plus 1 gives us a 1. So it's good to know this trick. You see, you can correct yourself easier. Okay? Then 180 versus 0. 180 versus 0 here. And it goes up again. 270 versus 1. All right? 270 and 1. 360 versus 2. 360 versus 2. So as you can see, if you have the table, it becomes easier. 360 and 2. So this one is for cos. So it's just going to be something like this. From the look of things, guys, it's going to be something like this. I don't know. But it was wise for me like to draw it like this. It was wise to be like inside now. I have already drawn, and I don't know if it's gonna make sense actually, but it's supposed to be something like this. All right, yeah, something like this. And pardon this part, guys, it's not a straight line. This one, it's a curve actually, like a curve actually. Okay, but for me it looks like it's no, it's supposed to be a curve. Okay, something like that. That is what you're going to have there. So this is our f of x here, which is the cos x. Then we do the same for sine. So it's 0 versus 1, 90 versus 2. So this is 0 versus 1 here. Mark our point. 90 versus 2. 180 versus 1. So just mark these points. 180 versus 1. 270 versus 0. 270 versus 0, then 360 versus 1. Is that so? 360 versus 1. So it's going to be like this one. Here to this point. All right. This point to 0 to 270 there. Then it goes back to 360 and 1 like that. So this is the one for sine, which is our gx for sine. So that is what it was just going to look like. Something like that, guys. As you can see, it's not something big, just like that. All right, so that is what you just needed, and just make sure that it's pretty clear, something like that, and you can answer the questions which follows. So the question is use the graphs drawn to determine the x values. So we need the values of x, where f of x is equal to gx. So whenever you want a condition where these two graphs are equal, that is at the point of intersection of the two. So these two graphs, they are intersecting here. That is their point of intersection. They also intersect here. So where f of x is equal to gx, that is the point of intersection. So this is the point of intersection, this one, point of intersection. All right, so if it is the point of intersection, what are the values? Because the question is the value of x. So what you need is you mark straight from that point here. So this one actually is in between there, straight to this point. So if we mark straight, pardon this diagram now, guys. If you mark straight like this, this is the answer there. And here also you mark straight 1, 2, 3, 4, somewhere there, in between there. It's because of the way that you'll be drawing these ones, but it's supposed to be in between here. these 2 points. So since this is 0 and this is 90 there, because this is 0 and 90, so in between 0 and 90 it's 45. So half of 9 is in between 180 and 207. You add 180 divided by 180 plus 2 cent, which is going to be 225. So there's a difference of, so actually here half of this box, because the whole box is 90, this whole box is 90, so half of it is 45. So here it's half, so it's 180 plus 45, which is 225. So these are the values of x that we're talking about at the point of intersection. Our x here is going to be 45 degrees and 225 degrees. All right, then cos x plus 1 is equal to 0. When cos x plus 1, this is the graph of cos x, which is f of x. So when f of x is equal to 0, you are referring to when it crosses the x-axis, that is when it is equal to 0. So this is your f of x, this one your cos. When it crosses, which means at this point here at 180, so this one is not going to cross, it's just passing through it, so it's at 180 there. So x is going to be 180 there. All right, then here when sine x plus 1 is equal to 2, what are the values of x? Okay, sine x plus 1, this is our sine x plus 1, which is gx. So this is our gx here. So when gx is equal to 2, this gx here, where is it equal to 2? This is our gx here, going here. This is your gx straight. This is at 2 here. So when it is at 2, this is the value when it is at 2. But what is the value of x? So the corresponding value of x is at 90 degrees when this is equal to 2. The question is asking the value of x. So x is 90 degrees at this point. All right, so this one is at x is equal to 90. That's 90 degrees. All right, then when cos x plus 1 is equal to 2 again, cos x, our cos x is from f of x. So when this, our f here is at 2, this is your f here. Where is it at 2? Where is here? This is where it is at 2. And at 2, what is the value of x? Straight to the x-axis, the value of x is at 0 there. So our x is at 0. X is 0 degrees. Okay, but that is not the only part, because here it's 2 and this our f, it started actually at 2 because this point here corresponds to 2 also, which is at 360 degrees. And x is going to be 360 degrees also. So these are the two possible values. As you can see, we've got 2 marks there, which means we've got 2 possible values that we're expecting from this. So as you can see, guys, that's how they ask these questions and so forth. So let's just see the other part, which is on question 5. As you can see, question 4, I think question 4, that's it, that's everything. So let's just rush and see question 5, which is ending up with the 12 marks there to make it to 100. So that's what we had on question 5, and it's nothing actually there on question 5. All right, so on question number 5, this is what we had. Below are the graphs of f of x. So we've got 2 graphs, f of x, this one, or f of x, and a straight line gx. This is a straight line, and a and b are the x-intercepts of f. C is the turning point of f. Both c and d are the, d is the y-intercept of both f and what? This point D is the y-intercept of both f and gx. All right. Then the question is to determine the coordinates of point A and B. So A and B, these are the points that you want. As you can see, A and B, these are the x-intercepts of what? Of this, our f of x. All right, so this is 5.1. Remember, our f of x is actually equivalent to x minus 3 squared minus 4, like this. So at a condition where we are talking about a point in the x-axis here, we know that y is equal to 0 in the x-axis. So it's just like solving an equation where y is equal to 0. So someone can actually expand this equation, or can just solve this one. When y is equal to 0, we shall have x minus 3 squared minus 4 like this. So we can transpose this, which is 4 is equal to x minus 3 squared. So this one is just the same as x minus 3 squared is equal to 4. Remember, if you are given a squared like that, you can easily introduce the square root both sides. X minus 3 is equal to square root of 4, which is plus or minus 2. So x is going to give us two values here, 2 plus 3. If you transpose this, minus 3 is going to be plus, or we have got minus 2 plus 3, which is another value of x. So your x is going to be 5, or another x is going to be 2. This is actually minus 2 plus, take note guys, this is minus 2 plus 3, which is 1. So that's another x. Or we could have maybe expanded this, all right, which is x minus 3 squared. We've got two brackets of x minus 3 like this, minus 4. So it's x and x, that's x squared minus 3x minus 3 and x, which is minus 3x minus 3 and minus 3, which is plus 9 minus 4, which is already there. So this is your f of x. So your f of x is going to be equal to x squared minus 3x, which is minus 6x plus 5, 9 minus 4, which is 5. So that's what you're going to have. And we are saying for the values of a, it's in the x-axis where y is equal to 0, which means f of x is equal to 0. That means x squared minus 6x plus 5 is equal to 0, like that. So you can do this even by factorization. Since the coefficient of x squared is 1, we are going to focus on 5. What are the factors of 5, which gives us minus 6? Minus 5 and minus 1. Factors of 5. If we multiply this, they give us 5. So you've got minus 5 and minus 1. So x is going to be 5, or x is going to be a positive 1. So these are the values of x that we are finding, but which one is going to be for the value of what? For the value of a and the value of b, because we want the coordinates of point A and B. So A is the one that is the least, B is the one that is more. So this one is our 1 and this one is our 5. But as a point, remember, a point is supposed to be a point like this. So therefore A is 1, 0 and B is going to be 5, 0. That's a point. A point is made of x and y. Remember that, guys, x and y. That's a point, okay? So that's our 5.1, just like that. Just like that, guys, just like that. All right. Then the coordinates of point D. So D is our y-intercept for both f and g. So we can substitute into our f of x. Remember, we have got two of them. So here we've got this one that we wrote it like this. So we've got, remember, our f of x is x minus 3 squared minus 4. Another one, it's f of x is equivalent. This one that we expanded, we ended up with x squared minus 6x plus 5. So you can substitute in any, because the point D is on the y-intercept here. It's on the y-axis, and in the y-axis, x is equal to what? X is equal to 0. So if x is equal to 0 here, we are going to substitute, which means our y is going to, in place of x, just substitute 0. So it's 0 minus 3 squared minus 4. Or you can substitute here, which is going to be 0 squared minus 6 into 0 plus 5. So you're going to see in both cases, your y is going to be a 5. So therefore, the point D is 0, 5. Remember, we said the point is made of x, and we said x is a 0 and followed by y, and y is 5. So it's going to be 0, 5, like that. So this is our point D, which is on 5.2. All right, so that's what we had. And on 5.3, the equation of axis of symmetry of F. The axis of symmetry is going to pass through the point of C, which is the turning point. That is the axis of symmetry. So the axis of symmetry, there are two ways actually. From this format here, you can find your equation of x of symmetry. The value of x, you equate this one to 0. X minus 3 is equal to 0. If you have got this type of a format, this one, you equate this one to 0. So your x is going to be 3, just like that. But if you are using this format, if you expand it to this way, your x at the axis of symmetry is going to be written as minus b over 2a. That is your value of x. And remember, we have got 1, it's minus 6, and 5, which is c. That's a, b, c. So it's minus b, which is minus b. Our b is minus 6, like this, over 2a, which is 2 times a. Our a is a 1 there. So using your calculator, it's going to be 3. So this is the value of x at the turning point. The value of x at the turning point is the value of x, which represents the equation for the axis of symmetry. So our x at this point is 3. Then the coordinates of C, which is the turning point now, because this is your C. We already have the value of x. All right, so that is 5.4. So using this type of an equation that we are using here, the turning point, which is the point C, we are going to take the value of x here from this equation, which is the x at turning point, which is 3, and the value of y is going to be minus 4. That's how you take it from this format. So y is going to be minus 4. That is from this equation. But if you expanded your equation to be like this, therefore you have to substitute here to find the coordinate C. So to find the coordinate C using this equation, since we have got the value of x at the turning point, therefore y is going to be, you substitute here 3. So it's going to be 3 to the exponent of 2 minus 6 into 3 plus 5. So you substitute in place of x, you substitute 3. All right. So you're going to substitute 3. Wherever there is x, you're going to substitute 3. And this is going to give you a negative 4. So that is, therefore, the point C is going to be the value of x at the turning point, which is 3, and the value of y, which corresponds to the turning point, which is negative 4. So that is going to be our point C. C is the turning point. So using this equation, you can take the turning point direct from there, from the equation, but using the other one, there's no way. So this is your point C, which is 3 minus 4, like this. Okay, this is our point B, which was 5, 0, and our point D, remember it was 0, 5. All right. Then the last question, to make it 100 marks, guys, to make it a total of 100, is the equation of the line GX. The equation of the line GX, and this is the line GX, this one. That's our GX. So as you can see, the line GX, it passes through the point B and it passes through the point D. So we have got 2 points, which makes it to be enough for us to find the equation, because it passes through the point D, which is 0, 5 here, point D, which is 0, 5. It also passes through the point B, which is 5, 0, and the point B, which is 5, 0, like this. So given 2 points, remember you can calculate the equation, because you need the gradient m from the format of the equation, which is y is equal to mx plus c, and our m, which is the gradient, is y2 minus y1 over x2 minus x1, which is your x1 y1, your x2 y2, like that. So you can just substitute, which is y2, that's 0 minus y1, which is 5, over x2 minus x1, which is 5 minus 0. So this is gonna give us a negative 1 as our gradient, or you could maybe just taken it from the graph. If you can do that, it's fine. So you've got our gradient there, which is minus y is equal to m, which is minus 1. So minus 1 can be just be minus x like that plus c. So c is the y-intercept, and we have the y-intercept. So guys, our y-intercept here, remember the point D represents the y-intercept, and the value of y there is 5. So just substitute there, y is equivalent to minus x plus 5, just like that. Or you can choose to substitute, maybe you didn't see that it was the y-intercept, therefore you pick any from these 2 points, you substitute in place of x and y there, in place of x and y, to find the value of c. You're going to see that your c is going to give you a 5, then you substitute into the equation. So guys, that's what we had from this question paper, which was actually written for the guys who wrote in March 2019, which was an X paper for mathematics N2. So that's what we had, combining with the first question that we did, and this part we have a complete question paper. So guys, what we need is to revise as much questions as possible, because we no longer have time. We are left with few days for our exams, so let's try and give it in all the energy and all the effort that we can, so that we prepare ourselves for the exams which are ahead of time. So that's it guys from Mason African Motives, till we meet again.